All right, here is how to use PathLinker to find the paths between root inputs and key outputs in Reactome logic graphs. So the first thing you need to do is go to apps, and I already have PathLinker, but if you don't have it, you can find it here. Like you can search for PathLinker, you will see it here. So for me, it says it's already installed, but if it's not installed, you can install it. And it will appear here on this sidebar. What we need to do first is we will open our recent file, signaling by notch 1 logic graph with DBIDs displayed. And then if we go to, so first we want to identify, let's say, we want to identify the root input and the key output that we have in our test case. So I will open this training data set, and so here we see root input perturbation is DLK1 downregulation. So DLK1 is the root input, and the key output, I already have the number here. So so I can already copy this, and I will, oh, actually, never mind. I will go here and okay, I will find this node. And so there is one node, it's here, it's shown here in red. So just for my orientation, I will bypass the style and fill this node in blue color. And then I will look for root input, which is DLK1. And you can see here two nodes highlighted. All right, so of these two nodes that, as we can see here, contain a DLK1 in their names, we can see that the root node is obviously this one, because it has no arrows coming in, it only has arrows coming out. And we will now bypass the style and color this node yellow so that we can see it easily. Okay, and now the next step is to use PathLinker to find the path between this root input node and this output key output node. So we'll open PathLinker here, and here we'll go to this field where it says sources, targets, and so here we insert source node. So in our case, this is the source node, the number of this node. This is the value we want to copy. We go here, we paste the number, and then we go to our target node. So it's this one, and we again copy with Control C. We copy the database identifier for that node, and I will just delete this extra space. And I want to allow sources and targets in paths. This is usually important to check because some, for example, this node is that it was selected as the key output of the pathway is not a terminal node. So selecting this will allow us to use to still calculate the distance. And I will just leave these default settings and I will say submit. So we can see here the subnetwork generated for this path. The path starts with the root input. This is, as you can see, this is the root input, and then it terminates with this pathway, and we can make this a sub network. We can make it look. We can make it show directions of these arrows and edge polarity by again going to the edge tab and selecting target arrow shape. We want to use the column edge polarity, and we want discrete mapping. Again, we want negative polarity to use this type of arrow, and positive polarity to use regular arrow. And so now we see that, and also if we want to display labels on edges to see the logic, we can say edge logic here. And but how that doesn't really display. Style. This is edge. This is label color pass-through mapping. Okay, so now it will display these, and we can change the label color to blue, so it's, and increase the font size so that it's easier to see. Okay, and basically, so these are, so we can see that we have multiple roots, but what's important to notice is that all these edges are positive except the first edge, which has negative polarity. And so this will help us conclude what the outcome will be, what the effect of perturbing this input node will be on this key output node. All right, so that's the end of PathLinker demonstration.